Very good. Good morning, good afternoon, everybody.
Good evening.
And good evening, good night. Actually, I think I have had people joining us from like some place that was 12 p.m., 12 a.m. in that. So I am Pablo. This is Daniel. This is the second video on the series of coming up to speed with Python, part of the bigger coming up to speed summer course that we're developing. And today we are going to go over the second part of our Python tutorials. So this is my screen. Can people online see my screen? Yes, they can. Very good. Okay, so we have come to the Ascension online guides. Maybe at the time that you're seeing this video, this has already been structured and it's not a bunch of Jupyter notebooks throw in there. So if you come in here, and then we're going to go over the Python packages. Let me open our code spaces. Let me open a new code space. And we're going to be able to execute things in there. So this is a cloud environment that we can do with Python. And it takes a while. Anything fun that you want to comment to our audience, Nadia?
If you told me beforehand, I'd have thought of something.
Yeah. It was a long week.
It was a very long
It was
week.
a very long
I
week.
don't know how you're still awake.
Yeah, me neither. Okay, so let's see Python packages. It was very nice. We click installing here. We were able to give the first lecture on the summer course, and I think that went well. Okay, this thing is installing. So if I want to run this, will ask me install, enable this thingy, and it's installing Jupyter. Should be done. Okay. Do you want to start telling us what are we looking?
Yeah, so this notebook, the goal of it is to get you used to how Python uses code that other people has written. There's an awful lot of things that you want to do that other people also want to do, and Python makes it very easy to take advantage of that. It does so using what are called packages. These are bits of code that are made publicly available that you can download and install. And then once you have them, you can just import them. You can bring them into the code that you've written, and that saves you an awful lot of time. For now, we're not going to go over how to get them or how to install them. So long as you run in code spaces, it will have most of the things that you might want to do just automatically. So the very first and maybe most important package that I use is what's called NumPy. It stands for numerical Python because it lets you do lots of elementary numerical things. To actually use it, you start with just the import statement. So this first statement here, import NumPy, says, hey Python, go find me the package called NumPy that I have installed somewhere and let me use it in the rest of the code. You see this, the next two terms are as and p. NumPy is 5 letters, NP is 2 letters. People don't like typing 5 when they can type 2. So you save it as a shorter variable. And this is pretty standard. For the most part, if you see somebody using np dot whatever, that means they're using NumPy. So NumPy is an awful lot like the classes we saw in the first Jupyter notebook. It has functions that you can access using the dot attribute. And so for the very first
sitting here, this is the dot attribute.
Yes. So the first thing we want to look at is how it compares to things we've seen before. So you've already seen how to create a list, and that has a whole bunch of numbers in it. You can create something similar in what's called a NumPy array by using the array function that NumPy comes with. And if you evaluate this and then you print it, you see that it actually prints the same, what looks to be the same thing.
This one has commas.
Yeah. So when you actually, I didn't even think to do it here. If you actually want to know what the class is of this, you go back to the previous notebook, and if you remember the types function, you'll see that my list is a list.
Okay, I should remember how to do that, but I don't.
Yeah, so it's 4 letters, TYPE.
TYPE.
And then parentheses, and then the variable name you want.
Okay, my list. Oops. Okay.
Yeah.
This is a list.
So it's a list because
Uh-huh.
I said it was a list.
And if we put an array, it's a NumPy ND array.
So, but it's ND array for n dimensions. So you
Okay.
can have 1, 2, 3, whatever.
Okay.
Fun fact, I learned the maximum you can have is 32 dimensions. If you have more than that, you have too much data to fit in a computer.
Really?
So that's what the internet said.
Okay.
So
So it must be true.
obviously.
Of course.
Okay. And you see, if you actually look back at how we created the array, what we've done is we've called a function, and the argument it took in was a list. And then we get out of it an array.
Mm-hmm.
The very first thing you can ask is, why would I use an array? Well, as promised, it makes your life simpler. If you want to do any algebraic operation you can ever conceive of, you apply it to an array the same way you would apply it to just a number. So you remember the double stars is for squaring it or raising to a power. You apply that to my array and it squares it. It squares every element.
So for example, if I were to add, instead of squaring it, I want to add the number 3. Will it add to all the numbers?
Yes.
Oh.
And
What
in
if
the
I
next
divide by 3?
it'll do the same thing. The
Okay.
next example is actually just scalar multiplication, and that works exactly as you expect.
Perfect.
So you'll see that NumPy implements a very large number of functions, such as the sine function, and the way they're implemented means they apply these operations to every element of your array.
Okay.
If you're feeling confident, you can try and do some of these operations applying to a list instead of an array.
How do I make the sine function?
NP
NP
tells you that it's getting from NumPy, then the
Uh-huh.
dot to tell, and then sine, S-I-N.
And then parentheses.
Yes,
So normal Python will not have sine.
correct.
Oh, okay. Yeah, it looks okay.
I don't know what the sine actually evaluates to for any of those numbers.
You don't know the sines of 1, 2, 3
Believe
in
it or not, I do not.
radians?
Although, given that 3 is close to 3.14, and it's smaller is a good thing.
That is a good thing. Yeah. Okay, very good.
But yeah, so this is one of the main reasons to use NumPy is because you want to do mathematical things to it, and NumPy evaluates them nicely.
Perfect.
Another very good reason to use it is in physics especially, data is sort of naturally multi-dimensional. If you're doing something on a table, on the plane, your natural coordinates are X and Y. And the conceptually straightforward data type that represents that is an array that has two directions, two dimensions. You have the rows, which might cover the X direction, and the columns, which covers the Y direction. And NumPy, again, makes making that array and using it very straightforward. So the next example here is creating a two-dimensional array.
That looks like a matrix.
It looks like a matrix. Sometimes throughout this, I might swap between matrix and array. I'll try and be consistent with it, but they're really not so different from a NumPy perspective.
So if I click here,
you've now made a 2D array.
Oh, okay. So, okay. If I were to ask, this should still be an ND array,
yes.
Right? My 2D array. Oh,
yeah, so they're all the same type, and functions that work for one will work for most of them.
Okay.
So again, if you wanted to, you could take the sign of this array, and it would work just as you would expect.
Oh, nice. Okay.
Yeah. Now, if you're clever, you see, again, when we created the array, we actually fed in a list of lists. Yep. And so if you didn't have NumPy, you could fall back to that. But again, algebraic operations are annoying when you have lists. Basically, NumPy is making everything easier here. Yep. There's a whole bunch of different ways to create arrays. There's common ones that you might want to do. You might want a constant array, an array with the same value in every place. You might want just the numbers 1 through 10 or 1 through 5. You might also want evenly spaced numbers. If you're working on some grid somewhere, you want to go this one and this one and this one and this one. And then the last one I show here is just random numbers. NumPy has very nice ways of generating random numbers. And this is very much a non-exhaustive list.
Yes, because Python is weird. This doesn't go up to 5, right? This go up to 4.
Right. Sure. Sometimes you see different things in the English language is just about as confusing as Python can be. To for or through for can mean different things depending on what you're thinking about. But Pablo got it in one. Yeah.
Okay, perfect. All of this makes sense. I'm happy.
Good. Now, you can also do clever things. You can reshape arrays. So in this example, I'm showing you maybe a quicker way to generate the previous array, my 2D array. The A range statement above gives you 0, 1, 2, 3, 4, 5, but it's just a one-dimensional array. And then you call the reshape function. So Pablo is going to do it maybe in
I'm going to move this thing in here.
Good.
We're going to print it. Array. Nope. And then, well, let's be specific.
We were just chatting about hard coding things in with Lauren. So
all right.
Good. Thank you. So you can see, you can reshape it, and this is useful in a number of situations. Certainly this example is a bit contrived, but sometimes you will see people store data tables to a file as just a flat array, and being able to reshape it is just a convenience thing more than anything else.
I didn't know this.
Really? Okay.
Yep.
Yes.
Actually, the other day, literally, like I think 3 days ago, for this paper that we were writing, somebody gave me a list of wave functions, and it was a concatenated list of like 800 wave functions, and I had to write an entire for loop. It would have been so easy.
So reshaping can be a little bit tricky. If you're familiar with other programming languages, C++ and Fortran order things, one orders by row and one orders by column.
Okay.
So reshaping, you have to be careful. I would suggest whenever in doubt, just print it out and see that it matches what you.
Yep, perfect.
And so with multi-dimensional arrays, you can do a lot of things. One of the nice things about Python, or rather about NumPy, is that it stores how many rows and columns you have in what's called the shape. So if you ever forget it, you can just say, give me array.shape, and that tells you what you want to know.
I am confused because this dot here makes it me think that this might do to the array is a class.
It is. It's an ND array class. And NumPy has a lot of methods that are implemented for the array class. So that shape tells you how many rows and columns. That size tells you how many total elements.
It's an instance of a class.
Yes, it's an instance of a class. Yeah.
Okay.
Yeah. So
I'm learning.
Very good.
I never knew why this was this way.
Yeah. So whenever you see variable dot something, it's because you made an instance of a class and you're getting some either variable or function that's associated with that class.
Wow. But then you can have classes that have classes inside because NumPy is a class.
Right, exactly. It's classes all the way down.
Okay, thank you for this class. Very good.
So there's various different scientific things you might want to do. You can try matrix multiplication. If you're unfamiliar with linear algebra, you'll see in one of the future courses that, of course, the shape of the array must be compatible. Again, NumPy, as a sensible Python function, has the same error structure as regular Python. You've tried to multiply a matrix that has 2 rows and 3 columns by a matrix that has 2 rows and 3 columns, and that doesn't work. So it raises an error that says, hey, this doesn't work. Depending on your situation, this may just be a problem, but if you want to do something like matrix multiplication, you can take the transpose of the matrix, and that swaps the rows and columns. Again, you see you're accessing a method belonging to a class. That's what the .key does. And in fact, you can, I do the actual matrix multiplication just down there.
Yeah, no, I just want to see it how it looks. So we're going to print this thing. This is how the original matrix looks like. And if you were to print the transpose, it looks like this. As you would expect.
Yeah, so you can do that. And then when you do the matrix multiplication, I notice here a shorthand, again, people don't like typing 6 characters when 1 character will do. So
Why
that's
say many words when few words do?
literally the reason for this. Did you know that there's a function that actually implements the addition operation? That's np.add or something to that effect? Yeah, but because people don't like doing that, they have the shorthands for algebraic operations.
Well, the symbol plus has been invented way before Python.
Yeah, so that was actually a design decision. I don't know how they did that, but it sounds annoying.
It sounds very annoying. Yep. Okay, very good.
Yeah, so you'll see.
So this is for matrix multiplication. You know that I also didn't know this.
Really? Okay.
Really?
Okay. Well, I work with
swear...
Python as my primary language, so.
Me too. For those of you at home, I am not pretending. Like I'm learning with you, so I'm very happy. Okay, perfect. So what is this?
So I'll point out before we move on, you're going to see an enormous amount of matrix operations when you look through the linear algebra notebook.
Yep.
So I'm not going to spend too much time here. The last thing I think I want to talk about with NumPy is how do I get things out of an array and how do I put things into them? Because I don't just always want to compute the range 0, 1, 2, 3, 4, 5.
Yes.
Well, you can get a particular element, just like you're accessing a list. You use the bracket operators to tell it you're getting an element of the list.
Yep.
Because you have a 2D array, you can specify the row and the column. Remembering that Python indexes from 0, you say, I want the 0th row and the thing at the 0th row and 0th column, and that's 0.
Because this is this element.
Exactly. You can do more than that. You can change it. You can say, set that number to 7. And it does it.
And it doesn't. Yep, very good.
You can also get in.
So yeah. I have done that here. If I came to print this thing now, it should read at 7.
Yeah. So that's one of the things you have to be careful about, especially when you're using Jupyter notebooks. Sometimes you'll change, this trips me up all the time. You change a variable in one cell down here, you go back and rerun a previous cell and get something completely different.
Yep. Okay, thank you, Daniel. That makes sense.
Yeah. There's lots of things you'll want to do sometimes. You can access the first row of an array. Point of weird terminology, despite the fact that it indexes from 0, people will still call it the first row of an array. So I'm sorry, you'll just have to get used to that. You can also access the column, and of course you can access the column by telling it you want the entire row.
Yes.
So that's what the colon thing does.
What will happen if I just put these two? Will it return everything?
Yes.
Oh, that's neat.
Yeah.
Okay.
If you want something really cool, put a comma there after that second colon.
This one.
And then type the word none with a capital N. Yeah, now print it. That's added a dimension. Now it has a row and a column and a depth. And you can put, I think, 29 more nuns there if you really want to. Yeah.
Okay.
Yeah. Yeah, so you've put...
I put more than 32?
I don't know.
I don't think so.
It looks like it. That's what it's saying. Number of dimensions must be between 0 and 32. You're close.
Oh my goodness.
Yeah, so you can see it doesn't even fit in there.
Oh wow. That is so fun. Okay. I actually was very lucky that the thing didn't crash. Okay.
Yeah. So there's
I didn't know this. Thank you, Daniel.
Tons of weird things you can do. And it doesn't stop there. You can do this whole thing is called indexing. That's the word you want to look for when you're trying to understand this. You can do a lot of things. You can get every other row. You could get probably in this example it makes sense. You could get the first column and the third column. You could get every other column. You can get columns in reverse order. You can get columns matching a different condition. It goes on and on and on and on and on. Obviously, I'm not going to spend the rest of the afternoon discussing every one of those examples, but there's a lot of stuff you can do. The NumPy documentation is pretty thorough. And in the notebook, you can see there's a whole bunch of different operations you might want to do and how NumPy implements them. So I'll let you read that in your own time.
Perfect. Fantastic.
The other package...
We're exploding.
Yeah, the other package I want to spend time talking about is matplotlib, because the other thing Python does very, very well is make plots. Once again, we're going to import it using our import statement. You see we have the dot operator here. We're implementing a sub package of matplotlib that's called pyplot.
Perfect. So if I wanted to confuse the heck out of everybody, I could import this as MP.
Yeah, you can do that. I think that's maybe the oldest joke in the Python language.
Really?
Yeah. Don't do that. I will say I have sometimes assigned a variable to NP, like number of protons, and then gotten super confused for like 45 minutes as to why it would stop doing NumPy operations at a certain point in my code. You can do it.
It's a bad idea.
It's a bad idea. It's confused.
Okay.
So, real quick, it's conventional to import all packages at the top of the script.
Yes.
Just for readability purposes.
Yes. So in a normal, if you were not writing a normal thing, this will be completely on top when you're importing NumPy. But for you folks at home, we're going to do it this way. Okay?
Yep.
So what do we have in here?
So first, we want to think about something to plot. I picked my favorite function, the sine function. You see I can use it just from NumPy.
Perfect.
And you see I've created a bunch of x values using np.linspace. So I've created 50 values between 0 and pi.
What is this E?
That's the scientific notation for powers.
Okay.
So that says it's 0.0 times 10 to the 0.0.
That I did know. I am asking for those that cannot ask.
I believe you, don't worry.
Okay, so what do we have in here?
This is going to be interactive. I'm going to ask you to play around with it a little bit and take things out. I've done it this way because I don't really understand how to add things to an existing plot in Jupyter. So let's go ahead and comment out everything below that first two lines.
Everything below these first two lines? So
leave that x.plot one.
Okay, so by the way, to comment, at least in this instance of
Colab. No?
Code spaces.
Code spaces.
Is I think control dash.
Okay.
You select everything, you put control dash, and it will put all these bounds that basically makes it green, and Python cannot distinguish green colors, so it will not run.
Yeah.
So I'm going to run this.
So there's only really two lines of code that we're running here. The first says, make me my plotting object, and then I add things to the plot by accessing the axis attribute.
To me, it has always been so confusing because sometimes you have the axe, sometimes you don't have the axe. I don't understand. What is that axe doing in here?
So I'll be honest, I don't 100% understand it either.
Okay.
What I know is that there's different methods implemented for the figure and for the axis. And so the axis controls the things you plot.
Okay.
So you'll create, I think Josh later is going to have some examples of making subplots.
Okay.
So if you have 3 rows and 2 columns of plots, each one has its own axis, and you can draw on that axis. The figure is the total thing. It includes all the axes. It includes the text telling you what the x-axis is and what the y-axis is.
Okay.
And so that's as far as I understand it.
Okay. Now, and why subplots instead of plots?
I habitually do subplots. If you only have one plot, which you do by default, it works the same as that.
Perfect.
Yeah. So first we make it, and then we put stuff on it.
We'll put label, sign, but I don't see it here.
Yeah, so that'll come later when in some of the stuff we just commented out. Yeah. So it's a very good practice to add axis labels, as I'm sure most of your professors have tried to
with units.
Inform you. If they have units, which most of them do, put units in it.
Okay.
We don't have units in this example.
I'm going to put units of meters.
Okay. You know we do nuclear physics, right? A meter is a very long distance.
Tiny meters.
Very good.
And then I'm going to put, what do we put units of this thing?
Call it an electron volt. I know that's also very low.
Electron.
No, that's very small for nuclear physics.
Volts. So is F something that transforms X into electron volts? Okay. So we're going to run this thingy.
Yeah.
Okay.
And so you see it added the X and Y labels. And I will say matplotlib can be a little bit annoying. There's a couple of different ways to do just about anything. So I've showed you just in these 2 lines of code, the 2 different ways to put axis labels on. If you scroll up a little bit so they can see it, you see you have in the top one where you set the X label, you have a specific function that sets the X label. There are reasons to use this one, but I generally don't use it. If you want to change the font size for the X label, for instance, you would use this.
This one.
Yes.
Yes, I could put like font size 20.
Yeah.
And now this is very big. Okay.
In most use cases, I find that I don't need to use that. So there's also the catch-all function x.set that just sets whatever you can think of. So you have something called ylabel, and you tell it ylabel equals string.
Okay. But then if you want to modify the font size of ylabel,
yeah, you would have to go back to set ylabel.
Okay.
So there's reasons to use both of them. As we'll see later, you can, without a whole heck of a lot of trouble, change the font size for everything everywhere.
Perfect.
Or the font style, at least.
Perfect.
So this is, I find, rarely necessary.
Very good. So we go to the next one.
Yeah. So we can add different things on here. And there's a couple of different things we can do. We can plot a function and go ahead and run it so they can see what comes out of it.
Oh, wow.
So you see in red, you can add a scatter plot. That's actually the third one down. But
cosines.
Yeah, so you have that. And you see we've been a little bit clever here with nesting some of the NumPy stuff. You recall I talked about indexing above. So within that brackets, we're plotting every other point in our range.
That's what these two things mean.
Yeah, so if that says, and this is how, if you put a -1 there, it would reverse the order.
Like in here?
If you replace the 2 with -1.
Because it's going in steps of -2. Right?
Now it'll do -2, yeah. It looks the same because it illustrates an XY pair. So it knows what the X is and it knows what the Y is regardless of what order it's in. But if you just print out data range -2.
Okay, yes, you're right. But for example, if I were to reverse this, that would reverse it.
Exactly.
Okay.
Yeah.
I hope you catch that. Okay, good.
Yeah. So you see there's a different function you can call that makes a scatter plot. For just about any different type of plot you want to make, there's a function that you can use to do it. And you see you can add in the second one above, that's making the orange curve, you can make a line plot that has a marker on it. So that's why the orange and the red curves are different looking.
Yep, that makes sense.
Then we want to add a legend, again, for readability purposes, a title so that your reader knows what you're doing. And you see, sometimes you want to modify the legend, but for the most part, it just knows what the color and the thing you're plotting are, and it does that automatically.
And I can increase the font size of this.
Maybe. Let's see if it works. Yes.
Oh,
again, if you're ever unsure of what options are allowed, just look up the function on the documentation. It will tell you, for the most part, what different things you can plug in.
What is it? What is the documentation of a function?
That's
have we talked about that?
We actually, I don't think we have.
I don't think we have.
Let's go back to NumPy. If you scroll up to the end of the NumPy section, because I think I have that there. If you, okay, so you see, I've linked here a beginner's guide. Go ahead, click on that. So this is the beginner's guide, which is very nice. It has a lot of things. I would recommend avoiding the advanced usage thing. Let's go to, honestly, probably it's quicker if we just Google NumPy documentation.
Perfect. NumPy documentation. So
you click on the 1.26 manual. Most of the versions are not going to be different enough for you to care about. So go to the API reference. And this tells you the different things you have. So I would recommend, oftentimes you'll still find it easier to Google for a specific thing and get to that specific page. But if we want to learn about the sign function, say, go to the top left for search the docs and type in sign, S-I-N probably, and hit enter. And you see it finds np.sign.
Oh.
So NumPy is maybe one of the better examples of this. lots of packages that I've written don't have very good documentation, and I don't plan on fixing it anytime soon.
Mhm.
But you can see it looks like a function. So functions take in arguments, and NumPy provides you, let's see, the documentation tells you about the argument and about the keyword argument.
Okay.
So remember, there were two different examples. X there, the very first argument, you have to provide.
Yes.
You want to evaluate signs somewhere.
Yes.
The rest of the arguments are keyword arguments. You can
Yeah.
provide them example values if you want. For NumPy, for the most part, you'll ignore the keyword arguments.
Yes.
But for matplotlib functions, you'll have lots of keyword arguments like font size.
Yes, these are optional stuff.
Right.
Yep. Okay. Very good.
So that's what I mean when I say documentation.
Perfect. Okie dokie. We have one extra stuff.
Yeah. There's lots of things you can change.
Mhm.
You can see on the x-axis, we've changed things.
Oh, the
I've told
things.
you. Yeah.
Mhm.
Like I say in the notebook, Matplotlib is typically pretty good about it. You don't have to set
Fantastic.
it, but especially for scientific publications, sometimes you want to.
Okay.
And there's fancy things you can do as well. This is going to change things.
Oh, because
So-
we have negative things.
No, it's because they're close to zero.
Yeah, and
Yeah.
negative things because we swap
Oh,
the
yeah, you
cosine.
do. Yeah.
Yep.
I didn't
Mhm.
even notice that.
Mhm.
But so you don't always do this. Obviously, it doesn't always make sense, but you
Mhm.
can do it if you want to.
To set log scale. So if I were to now, for example, the two problematic negative things is the sine, so I'm going to comment that out, and the cosine, so I'm going to comment that one out, and that should give us a nice
Exactly.
log plot. So this is an exponential, but it's a log. Okay.
Yeah.
Yeah, perfect. Okay, we continue.
So I'm not going to go over
We said
the
that we
rest
were
of
going
the different
to
options.
finish earlier today,
Yeah.
and here we are. That is okay.
There's a gajillion options. I
Mhm.
list out a few of them. The last thing, let's see, those are all things you can Google for. One of the things that I didn't encounter until a ways into my PhD is how to actually make publication quality plots.
Yes.
Those have specific font qualities, and this is just repeating the same code from before with 2 extra lines at the top. Oh, I wonder if it's gonna work for you. No.
Because we don't.
Okay,
Well, this
so
is great.
this is an example of something.
What happened here, Daniel?
Yeah,
Why
so
my plot is not plotting?
so this is an error not with the plotting at all. This is an error with importing. So this is something I totally forgot about. I said we weren't gonna have problems with it, and then the same notebook we have. So you see, it tells you it can't find it. Module not found error.
Mhm.
So that means you need to install it somehow.
Okay, and that's what we're going to do because
Yeah.
luckily I know how to do that.
So you can click on that GitHub link, and that tells you what it is. Oh, really?
Well,
Okay, then I'll try and fix that because I thought that would work.
but I know how to.
Oh no, sorry. Can you copy the link? Copy and
I
paste
can
the link?
edit it.
Yeah. Okay, I kind of thought that would work, honestly.
Okay.
But okay, I don't know why that. Okay, we'll fix that in post.
Mhm.
So if you scroll down, it tells you why you would want to use it. It gives you some
Wow.
examples of what it does. To install it, I guess we are going to discuss this because despite me thinking I'm not going to.
Mhm.
The default package manager in Python.
Mhm.
Okay, when I say package manager, it manages your packages.
Mhm.
It manages NumPy, matplotlib, all the things. It installs it at one place in your computer and you can access it from anywhere.
Mhm.
The default package manager is called pip, and I don't know what that stands for.
Pip.
But we're going to run that.
Pip install
I
science plot.
I think you have to, because you're running it in Jupyter, you might have to do like a parentheses sign.
I'm almost sure that this works.
Okay.
It's collecting, download it. It always says no. You may need to restart the kernel to use this, and I have never had to.
Yeah.
So we're going to comment this because I don't like all those letters in there. And now, do you think it will work?
Hopefully.
Import science plot. Well,
let's see.
Oh,
maybe you do have to restart it.
Fail to process a string with text.
Okay. So let's skip this example then.
Okay.
So if we just look at the GitHub, you'll see what it can do.
Okay.
It makes the plots look nicer.
Yeah.
And if you're running this at home, you can see it should have the output already saved in it, so you can just see what it looks like.
Yes. Weird. So we'll have to install later. We'll come back to
Yeah.
that later. Okay.
Yeah, you have to install LaTeX because it's using LaTeX fonts.
Yes.
That's so. And then if you don't like it, it took me forever to figure this out. At the very top there, yeah, you can just change it back. Change all the parameters back. So it'll change the fonts, the font sizes, the font colors, everything changes back, and your plot looks like normal.
So I should run this?
Yeah. I think you just added a.
Yes. Okay.
Hold on. So that's fine.
Mm-hmm.
I'm going to recommend that when you have lots of things that you want to do, you follow this link to the gallery. So go ahead and click on that. We'll give them a little bit of a spoiler of what's
This
there.
one?
The bottom one, outside of the list.
Okay. Wow, 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 wow.
Yeah, so these are the examples. It just keeps going and going and going.
These are so pretty.
Yeah.
Are these smiley faces?
Yes. Which is very funny and very cute.
I love these.
So
exactly, I just gonna follow my page. Wow. No way. This looks incredible, Daniel. Thank you.
yeah.
You know that I have other things to do today. Wow. Wait, this goes on and on and on.
Yeah.
What is this? Wow. Wow.
So I would recommend going here if you have questions. Pablo has also had fantastic success with ChatGPT.
Yeah.
So
yeah. Wow.
I don't know what this is doing, but it's doing something cool.
And it looks super cool. Wow. Okay. Okay. Yeah. Let's stop being distracted. This is interactive plots.
The very last thing, this is Plotly. I only added this example recently. You'll see it again when we get to the discussion on Taylor series, because Josh wrote this code and we'll use the same thing.
So this is a different package.
Yes. Plotly is a different package. It lets you do interactive plots. We just saw some that you can do during Matplotlib. Plotly is also useful, and it's fantastically useful if you want to make a website that has interactive elements.
Yep. I'm going to run this. This function has nothing to do with Plotly. This is just to create a Taylor series. So we run this whole thing. Okay, well, what is he saying? NumPy math is deprecated.
It's complaining. Okay. Don't worry about that.
Okay, let's ignore it.
So
what do we have here?
You see the blue curve is the function we have. The red curve is the thing that we're going to change by changing our slider. If you know what a Taylor series is, the red curve is the order of the Taylor series. It's a Taylor series of a given order, and we control the order with the slider bar. So if you click it over one, it's quadratic, cubic, and so on and so forth. And if you keep going, you see, as you expect from a Taylor series, it just gets better and better.
This is so pretty. I love it.
The reason we're showing it here is, again, to show you what Plotly can do. You can add multiple slider bars. You can do a lot of things. We can take a look through the code very briefly.
Yes.
If we can drag ourselves away from the cool thing. So similar to Matplotlib, you first define the things you want to plot. Then you make the figure that you're going to be putting the plots on. And then you say, when you make plots with Plotly, what the function call is adding trace. I don't know, again, the terminology escapes me, but it's saying add a scatter plot, except because I want to make it connected.
I want to make a point because whenever you do this, you're importing a specific function from that thing. You can call that directly instead of calling it through class.
Yeah.
Because you see that Daniel just calls make subplots as if this was a function, but we never created this function.
Yeah. I will point out, despite me doing that in this code, it's typically bad practice. It's nice to know where the function comes from. And so you want to import it that way. If you're the only one using your code, nobody's going to care. So.
Yep. But you should always do your code thinking that other people will use it.
Yeah.
Yep.
So you add a trace, which means I'm going to add an interactive plot element, and I want it to be a scatter plot. Perfect. And because I want it to be connected, I tell it that in the keyword arguments.
What? What is connected?
Mode equals lines. That's if you.
Oh, okay. Yeah. Connected the. Oh, yeah.
And then I say I'm going to make a Taylor series, just a linear order. Plotly can be a little bit weird to wrap your head around. When you're making interactive elements, you'll typically want to add a default value. So that if the user hasn't done anything, that's what that is doing. Then the rest of it is saying, I want a list of things that I want to
be updated if the user does something.
Exactly.
Perfect.
So for every value in my slider bar,
Yep.
I make another trace.
Yep.
And then I can make the slider and tell it to make the interactive elements.
Very good.
And once again, it has a lot of examples here. If you click the link down to the bottom.
For example, it says Taylor series approx n equals 1. We could have made it in such a way that this n also changes, but the user is in what
Yeah. On the right there, in the last text below the plot, you see examples. This will also blow your mind.
Wow, 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 wow. And these are interactive?
So I think a lot of them are, yeah. In general, you can see even when you just hover over it, you see that it's interactive. So some of the default things are interactive. And again, the list of examples just goes on and on. I have to be honest with you, I don't find Plotly super intuitive to use, but ChatGPT works very well. It works very well for interactive elements, and there's tons and tons and tons of examples.
Sorry, I'm just so.
This example.
Oh wow! Oh wow! No.
Yeah. So I wouldn't even bother making 3D plots in Matplotlib. Not when you can do this.
No, this looks like a video game. Oh my goodness.
I feel like video games look a little bit better, but maybe that's just me. I wonder if somebody's made a video game in Python.
Yeah, I mean, imagine, yeah. Wow, wow, wow.
Yeah.
Okay, I'm in love.
Yep. So there's tons and tons and tons of stuff you can do.
Okay.
And I would recommend obviously using the packages and copy pasting from examples that people have already
I'm playing with it. That's why it's like a video game.
Yeah.
Fantastic.
The last thing I close this notebook with is a bunch of resources, just some of the common packages I use and what I use them for. So there's things that deal with moving files around on your computer, more things for scientific computing. You've got machine learning tools, you've got special functions and optimization, again, the plotting libraries, and things for file input and output.
Fantastic.
And if you want, you can even go to bmax.dev.
Yeah, I saw it. Very nice. This is
an example of something one of the undergrads we've worked with made using Plotly and Dash.
Yeah. Oh yeah, this is very nice. Fantastic.
Pablo, do you have any more questions on this?
I don't think so. Let me stop sharing screen so we can say bye. This was awesome. I'm so impressed how I keep learning things from you, really. Yeah, so I do we know what we're going to do next in our Python thingies?
I don't know.
Me neither.
I've been talking with Josh about the Taylor series notebook. He's going to provide some of the examples that I think they'll have seen in the class.
But what is
something you want to learn about Python?
Oh. I don't know. Perhaps something that I would like. I don't know if this is the next thing that we should do, but something that I would like is to sit down and do a task from the beginning to end. That task could be something that your research colleagues might have asked you to do. Find the optimal way of arranging that we need to start from the beginning. So that process of mixing thinking abstract ideas in math with how you will tackle it with code, perhaps is something that we can do. We can do 2-3 examples of starting with loose defined objectives and through code showing how you end up with whatever you need, including searching online for documentation. It's like, I have no idea how to do this. So
you're going to see exactly how often I actually mess up writing the code.
That's very important to show, because all of this code that you show, how long it took you to write all of this?
Probably an hour and a half or something.
Well, he's a master, but it would have taken me much, much more. And it's not that code just comes out of your fingers.
It's in some ways more of an art than a science.
Yeah.
So I think that would be enlightening. I think it would be stressful, but I would love to help out.
Okay, perfect, fantastic. Well, that's all for us today. Anything else you want to say to our audience?
I hope the summer course is going well. And if you're not part of the summer course, I hope whatever you're doing is going well.
Oh, fantastic. Well, thank you, folks. Join us for the next time where maybe we'll do stressful things. I hope you found these useful. And for those of you taking the course, I will see you Monday. Bye, friends.
Bye.